Today we will be discussing more about yesterday, like we were talking about, there are certain pre-steps before this, whatever exercise we have done is we have done on a finished data set. However, when we are handling some data set, there are many problems coming. So how to handle that data set? That things we will be looking at, and we will also be looking at what are the pre-steps to be done. For example, testing of stationarity, testing of multicollinearity, heteroscedasticity and autocorrelation. These are the basic things which we will be doing today, and then we will be discussing briefly about some of the advanced topics in panel data. So I'll just give you a glimpse of what are the topic and what are the kind of data sets we can handle. Now, first of all, I'll first tell you what are the different type of data sets we can have and what are the different techniques we can apply. Right? So your first thing, so whenever you are having any data set, first thing whether you have to test is that whether all the variables are simultaneously stationary or not. Okay, so the first thing, so whenever you have a data set, the first thing which we have to test is that whether the data is stationary or not, and then we have to decide on the model. So for stationary data set, we have to have some different type of model, and for non-stationary data sets, we have to have a different type of model. However, always remember that whenever we have a data set which is not stationary in the base form, it has to be first converted into stationary. Okay, again I am repeating, please try to understand this thing carefully. So my first thing is that I will check whether my data is basically stationary or not. If my data is basically stationary, I will go for some normal model, plain models. However, if my data is not stationary, I cannot go for normal models, I have to go for certain other technique. But whichever technique I am going for, I have to first convert my data into stationary. Right? Sometimes what happens, this process is done by the software itself, sometimes we have to do it manually. Sometimes the stationarity can be done by the model itself, sometimes we have to explicitly do it. What is the best manner of converting a data set into stationarity is to taking the first difference. Okay, so rather than, like we were talking yesterday in case of dynamic panel model, today also we will be talking about little bit about stationarity, what does it mean and why it is so critical. So whenever my autocorrelation is very high, in the magnitude of almost equal to 1, so we say that we are having a unit root. We say that we are having a unit root. What is the meaning of the unit root? It is very simple, like in our again this is all derived from our childhood mathematics. In our childhood mathematics, we used to have functions and equations, right? And we used to say that there are certain roots of a function. We used to derive roots of a function, right? So unit means 1. Unit means 1 and root means nothing but the root of a function. That's all. So just to confuse you, they have called it unit root. You can simply call it when the root of a function is 1. The series is not stationary. But it is in a technical terms called as if an equation has a unit root, it is non-stationary. So what is this unit root? Unit root nothing but I am having a function whose root is 1. It means my today is perfectly correlated with my yesterday. So my today is perfectly correlated with my past, and hence it becomes a unit root process. Now see, there can be 3 things. One, my today is related to my past, but it is not 1. It is very less than 1. So it can be 0.1, 0.2, something like this. If that is the case, I have a stationary process. If I am perfectly related with my past, that is I am having a unit root. Root of a equation is 1. Nothing, don't have to worry about unit root. So root of a equation is equal to 1. Then we have a non-stationary series. And if the root of the equation is greater than 1, it is called the explosive series. So basically you can have 3 types of series: stationary series, non-stationary series, explosive series. Stationary series, non-stationary series, and explosive series. Stationary means my root is less than 1. I don't have a unit root. So many people confuse between whether unit root and stationarity, what is the relationship between them. It is very simple. If a series has a unit root, it is non-stationary. If a series has unit root, it is non-stationary, otherwise it is stationary. So if my root is less than 1, I am having a stationary series. If my root is exactly equal to 1, I am having a non-stationary series. And if my root is more than 1, I am having a explosive series. Okay. Sometimes to confuse you even further, rather than calling them series, we also call it process. So we will say that we are having an explosive process. Right? And you will keep thinking, what is this explosive process? Where does this explosion happen? Right? It simply explosive process means I am having a series whose root is more than 1. That's all. Don't have to get confused. Okay? So stationary process, then I have a non-stationary process, which is also called as a unit root. And then I have an explosive. Right? Now, this process is very difficult to handle and difficult to model. This is done in a very advanced stages. Very advanced stages. Right? Hence, we will not be discussing about it. Our major focus, and this will not be a kind of, so you also don't have to worry much, because most of the data set you will be having will not be this. This is a very technical and very specific type of data set which we generally don't deal with. In social science we don't deal at all. Right? So we don't have to worry. Now there are 2 things, stationary and non-stationary. If my data set is stationary, I can perform any form of regression. Means this is my starting point, not the finishing point. So if it is a stationary process, I am having a prima facie evidence that yes, I can perform regression. Okay? Which form of regression we will still have to decide. We have not yet decided, but here, if I am having a non-stationary process, I cannot apply directly any form of regression. So whether it is your normal regression, whether it is your ARMA, whether it is your ARIMA, whether it is your ARCH, GARCH, any of these processes I cannot apply in a non-stationary. So regression based techniques can only be applied in stationary data. If it is a non-stationary data, I have to convert it into stationary in order to apply any form of regression. Right? So if I am having a stationary data, I can apply any form of regression. If I am having non-stationary data, I have to first convert it into stationary data and then apply some form of regression. Right? Now, coming to stationary data. In stationary data, first I have to test with my dependent variable. First thing I have to test is my dependent. Okay, here one more thing. Stationary means all the variables are stationary. Okay, so you have to check stationarity for all the data which are in the ratio scale. Stationary can only be tested for data which are in ratio scale. If your data, some of the data is non in ratio scale, like suppose your data is in ordinary scale, or suppose you have a dummy variable, you don't have to check for stationarity. Again I am repeating, if your data set consists some of the variables which are not in ratio scale, you don't have to test for their stationarity. Stationarity has to be only tested for the ratio scale variable and which have a sufficient number of time series. Right? Sufficient is not defined, but it is generally mean that whenever you have more than 7 to 10 data set in terms of time, then you should perform stationarity. Okay, so suppose if I am having 2 time period or 3 time period, I cannot perform stationarity. Stationarity makes no sense. So for stationarity, generally we say that there should be minimum 7 to 10 times observations. Right? So whenever I take a data, what is the first thing I have to do it? First thing I have to understand its nature. Then I have to identify whether it is cross section, time series or panel. If it is a time series data or a panel data, I have to check for stationarity. If the data is stationary, I will do certain types of processes. If the data is non-stationary, I will do certain other types of processes. So, first thing is stationary. So, all my variables should be stationary. So, if I am having one dependent variable and 6 independent variables, I have to test stationarity for all these 7 variables. Okay? Again, I am repeating, if I am having one dependent variable and 6 independent variables, I will test stationarity for all these variables, all these 7 variables. Once I ensure that all the 7 variables are stationary, then only I will go ahead. Otherwise, I have to do some modification. Right? So, first thing in any kind of time series data or any type of panel data is to test for stationarity. Now, once we have accepted stationarity, the stationarity can either be accepted or it can be rejected. If it is rejected, it means it is a non-stationarity. So, it is accepted, it is rejected. Once it is accepted, then I have to first check the nature of my dependent variable. Okay? My dependent variable can be of 2 types. One is a ratio and one is a nominal. Nominal simply means dummy. We were talking about dummy, we had talked about dummy variable, but we were talking about when the dummy variable is an independent variable. Now we are talking about a dummy variable which is a dependent variable. Again I am repeating, earlier we were talking about dummy variables which were independent variable. Now we are talking about dummy variables which are your dependent variable, left hand side variable, right? Now if I am having a stationarity process, first I will test for my dependent variable, whether it is a ratio scale or whether it is a nominal scale. If it is a ratio scale, I can apply any of the techniques, okay? So suppose if it is a normal regression, I will apply, so I can apply here pooled data regression, I can apply FEM, I can apply REM. But if I also have a dummy variable in my explanatory variable, I cannot apply FEM. I have to only apply. Sorry, any question?
So what you said, if you have done.
Okay, I am repeating. First, I will test for my dependent variable. My dependent variable can either be ratio or it can be nominal. If it is ratio, I can apply three types of technique: pooled data, fixed effect model, or random effect model. Pooled data also means plane regression. So suppose my data is not in a panel form, it is a purely cross-sectional or purely time series data, then I will apply plane regression. So you can also add one more thing here. So pooled data or plane regression. But if my data is in a panel form, I have to either apply fixed effect model or a random effect model. However, if in my independent variable one or more variable is a dummy variable, then I cannot apply FEM. I am again repeating, in my independent variable, if I am having any variable which is a dummy variable, I cannot apply FEM, I have to mandatorily apply REM. Right? If it is a nominal data, then there are three basic types of models which have been proposed. One is logit, one is probit, and one is topit. Were some of these discussed? No. Okay, no issue. Just for the time being right now. Just for the time being, go with the flow. We will understand one at a time what is happening and see. Due to certain time constraint, we may not be able to actually see their estimation process, but we have to understand, bare minimum understand in which situation which kind of data has to be, which kind of technique has to be applied, and how to apply that. There are many good references available. I will share with you many good references. All these things can be easily applied. However, you should be clear with your objective. You should be clear with your objective, you should be clear with your data. So, clarity of objective and clarity of data. Now, nobody in this world can tell you how to bring clarity of objective. You have to make your objective clear by yourself. There is no technique in this world which can make your objective clear. There is no technique. You have to understand, you have to do literature review, you have to ask your experts in the field, you have to maybe there are certain preliminary exercises, like in marketing we generally go for focus group discussion, we go for in-depth interviews, we go for conducting surveys. So there are many methods to get preliminary information. So if possible, you try to get preliminary information, and based on the preliminary information frame your objective. But your objective has to be clear. Once your objective has to be clear, the data will automatically follow. And once you have a data set, you know what kind of technique we can apply. Right? So always remember, if my objective is clear, I will be slowly visualizing my data. If my objective is clear, I will be slowly visualizing this data, and once I will be having my data with certain tests. So there are ready-made tests for checking stationarity. Then my dependent variable is the ratio scale or nominal scale, I know. Then whether I have to apply pool data or panel data, I told you there is a test of homogeneity. Then whether I have to apply FEM or REM, there is a test called Hausman test. So once your objective is clear, once you start visualizing your data, all the techniques will follow immediately. And you will be able to give a proper rationale. Because I want to do this, and because I have collected data like this, and hence I am applying this methodology. It makes sense. But if you say, just because I attended a workshop in Patiala University where somebody told me that Tobit, if you write Tobit and I will publish a paper, and hence I am applying Tobit, please don't do that. Okay? You are applying not because you know it. That is a necessary condition, not a sufficient condition. You have to know methodology, it is good. But you are applying methodology because you know it, it is not good. Like, for example, ma'am, what is your name? Dilraj. Right? Now, Dilraj is having a small fever. She goes to a doctor. Now, she says, Doctor Saab, I am having fever. Can you cure me? The doctor says, see, fever and all is very small thing. Okay? I know how to do operation. So, I know how to do some kind of stomach surgery. So, I will do your stomach surgery. Because I know, I attended a workshop. In that workshop, they told me that if you have to become a renowned doctor, you have to do more and more stomach surgeries. And hence I will do stomach surgery on me. What will you do? Run away, right? Similarly, if you do something like this in your research, the editors will run away. The editors will run away and you will be chasing them. And you will not be knowing why are we chasing them. I am using the best methodology. उसमें वर्कशॉप में मैं इतना पैसा खर्चा करके गया, उसने बोला टॉपिक अप्लाई करो, मैंने टॉपिक अप्लाई किया, डेटा नहीं था फिर भी वैसा डेटा क्रिएट किया, ऑब्जेक्टिव नहीं था फिर भी ऑब्जेक्टिव लाया. ठीक है? It will make no sense. So whatever you are applying should make sense, right? So I know it is the most painful process. It is the most painful process, but believe me, once that process is done, this all will become very systematic and very relevant. Then only you will be able to appreciate why I am applying panel. So today I'll ask you why I am applying pool data, why are you applying pool data, why are you not applying panel data, you should be able to answer. Because my purpose is not to check heterogeneity among groups. My purpose is to check pure relationship, and hence I am applying pool data. Or because there is heterogeneity and the error term is following certain distribution properties, and hence I am applying REM, it makes sense. You are able to give a valid answer. But why are you applying REM? Because this is the only technique I know. My guide says that I have to publish 2 papers before I can submit my thesis. I know only one technique, REM, and hence I am applying REM. Otherwise, my guide will not accept my thesis. This is not a valid option. I mean, it's a crucial thing for you, but for editor, it is not a crucial thing. Right? So editors are, in that sense, sometimes ruthless. They may simply reject a, you might have done lot of work, but they may simply reject a paper just because they think that your objective is not well defined. So always make conscious effort and spend some time in well defining your objective. So if this is clear, now let us see what are the different types of techniques we can handle. Some of the techniques we will discuss, some of the techniques we may not be able to discuss in detail, but I will give you some good references which you can, go back, refer and practice. So first thing, data, either it is stationary or it is non-stationary. Then if it is stationary, I will say dependent variable. Dependent variable is in ratio scale. I can go for pool data, plane regression, FBL or RBL. Similarly, if it is a nominal data, I can use logit, profit and profit. Now what is the meaning of logit, profit and profit? See, whenever I am having a dummy variable in my dependent variable. So for example, in some marketing research, we try to understand, like in a shopping mall, there are many customers which are coming, right? Now I want to find out whether a customer will buy or not. What are the factors which will define the purchase? Okay, so let us say out of every 10 customers, 3 are buying and 7 are not buying. This is just a random order. So what I will do, whoever is buying, I will give them a value 1, and whoever is not buying, I will give a value 0. Why I am doing this? Because I am only interested in understanding who is buying and who is not buying. I am not interested in understanding what they are buying, how much they are buying, from which shop they are buying. I am only trying to understand that if 100 people come, how many will buy, how many will not buy, and what are the factors which will influence his buying. What are the factors which will cause him to buy, or what are the factors which will cause him not to buy. Right? So what I will do, I will create a data set like this. Right? So I will call it as a buying function, buying decision. Okay, so buying decision would be like 1 0 0 1 1 0 0 0 0 1 0 0 1, something like this, right? So 1 represent a person who is buying, 0 represent a person who is not buying. Now look at this very carefully. I told you earlier, whenever we are doing any regression equation, what is the formula of beta? Covariance xy upon variance of x. Simple formula. Now think carefully. X is my independent variable, y is my dependent variable. If I have an independent variable here, this is the dummy variable and there is an independent variable here. If I find covariance x and y, will it make any sense? Will it make any sense? So covariance between a ratio scale variable and a categorical variable, does it make any sense?
No.
In fact, some of you were yesterday asking me about R square in panel data, or R square whenever we are using a dummy variable. I told you R square does not make any sense, because R square is also based on this formula covariance. R square is nothing but your square of your coefficient of correlation, right? So R square is nothing but the square of correlation, and correlation is nothing but standardized covariance. That is, correlation equal to covariance xy by standard deviation of x into standard deviation of y. That's all. Very simple. So I am telling the covariance does not make sense. If I standardize something which is not making any sense, will this standardized value also make sense? I am trying to make some sense out of nonsense. So this is not relevant. If this is not relevant, then I am squaring that also. Something is irrelevant, I am standardizing it, then I am also squaring it. Right? Is it going to make sense? It is all nonsense. So this value is. So always remember, whenever you are having a dummy either in dependent variable or your independent variable, your R square does not make any sense. And if you have a dummy in your dependent variable, your beta also does not make sense. Means this formula of beta, we have to modify the formula of beta. Is it clear? Getting tough? Not able to understand? Any issues? See, this is for first time, so you may take some time to settle down, but try to understand what is happening. Are you clear with the formulas? You know all these formulas, right? So just look at the formulas and see what is happening. Are you able to see everything? Are you able to understand? You understanding? Anybody, any doubt? You can ask me the doubt now, then we will move. Right? No problem. Even if it is a simple doubt, we will. Any doubts? Then we will discuss. Now we are talking about data set which is purely stationary. If it is non-stationary, we have to do certain modifications, right? Okay. Again, I am whatever I have said, I am coming back once again. Okay, everyone, let us start from some basic concept. Try to understand this. So whenever there are two variables and I have to find their co-movement, if there are two variables, I am trying to find their co-movement, it is called as covariance. Again, all these terms are there to confuse you. There is nothing big deal in this. अगर आप उसके डेप्थ में जाओगे एकदम आपको क्लास 7th 8th का मैथमेटिक्स याद आएगा. कुछ भी नहीं है. It is all based on your class 7th 8th mathematics, mean, taking the difference, that's all. Nothing great deal is that. Only thing is that there are two variables. For example, GDP and capital formation, or interest rate and exchange rate, education of a person and his income, or income and consumption. All these things are found to be vary with one another. So how much they are varying with one another, if we have to quantify it, there is a formula called covariance. Covariance of x and y is nothing but summation x minus mean x into y minus mean y whole divided by n. So what I am doing, I am differencing x from its mean and also differencing y from its mean, and all the individual number I am multiplying them. So x1 minus mean x into y1 minus mean y plus x2 minus mean x into y2 minus mean y plus x3 minus mean x into y3 minus mean y plus dash dash dash. I am doing this process, adding them up, dividing by number of the terms. This gives me covariance. Is it clear? Now there is also something called standard deviation. So it's like covariance tells us how two variables are moving together. Standard deviation tells us how one variable is moving on its own in terms of its mean. So there are two variables. One variable is having a smaller standard deviation, one variable is having a larger standard deviation. It means the first variable is moving very little bit in terms of its mean, whereas the another variable is moving very high in terms of its mean. So standard deviation of a variable x is again nothing but under root summation x minus mean x. That's all. So I can find out standard deviation of x, I can find out standard deviation of y. I know covariance. So what I do, if I divide covariance by standard deviation of x and y, I will get correlation. So correlation xy is nothing but covariance of xy whole divided by standard deviation of x into standard deviation of y. Now why I do correlation? Because correlation is having certain very beautiful properties. What are the properties? Suppose I am having two variables x and y. Right? If I find out their correlation, any two variables x and y, if I find out their correlation, it will always lie between -1 and +1. Your covariance can be any number, 2000, 150, 70. Making sense out of covariance is difficult, but making sense out of correlation is very simple. Correlation will always lie between -1 and +1. Right? One thing. Second thing, suppose I am having a series x. If I multiply all the numbers of so I am having a series x and y. Suppose their correlation is 0.8. If I multiply all the values of x by some constant, let us say 3. So I will be having 3x. I am having a value y. If I find out their correlation, it will again be 0. Again, if I multiply this also with some another number, let us say 2. So I will have 3x and 2y. It will be again. I multiply x by 3 and add all the number by 4. 3x plus 4. I multiply y by 2 and add by 7. So it will become 2y plus 7. The correlation between them will also be 0.8. So correlate in technical terms, they will not say this. In technical terms, they will say correlation is independent of origin and origin and scale. Scale invariant. So in order to become famous, what they will not say this. They will say correlation is independent of origin and scale. अब आप समझ नहीं पाओगे origin कौन सा है इसका, scale कहाँ पे आई, कौन सी scale हमने क्या किया. Nothing. They are only telling this. So whether my origin is 0, 0 or my origin is as 4 and 7, my correlation will be same. Whether my scale is pure x or my scale is 3x, whether my scale is pure y or it is 2y, it will remain the same. Hence, we always use correlation and we do not use covariance. This is clear? So far this is clear? Now there is only one thing and which will make your regression always clear. Now correlation, there is no distinction between dependent and independent variable. If you want to write down, you can write down this point. In correlation, there is no distinction between dependent variable and independent variable. In correlation, there is no variation between, in correlation, there is no distinguish between dependent variable and independent variable, and hence correlation is symmetric. Hence correlation is symmetric. Right? Symmetric, again I am using this word to become popular. Symmetric means if I do correlation x and y, or if I do correlation y and x, they will be same. Because x is also getting equal importance, y is also getting equal importance, and hence it is symmetric. Correlation between x and y is equal to correlation between y and x. However, in regression, we don't do this. What we say, there is something called dependent variable and there is something called independent variable. I cannot treat them symmetric. So what I do, I find a modified form of correlation, which I call it beta. I find out a modified form of correlation, which I call it beta. Beta is nothing but your slope. Right? So in this formula, you can see covariance xy by standard deviation x and standard deviation y. In regression, I do one simple thing. In regression, I do one simple thing, but I don't tell you that कि I am modifying correlation because I want to become famous. So I will call that it is beta. What I do, one simple thing, I will remove the standard deviation y. And rather than here, I will bring standard deviation. ठीक है? तो ग्रेवी हमारी सेम थी, हमने पनीर की जगह चिकन डाल दिया तो बटर चिकन बन गया, ठीक है? वो कोई नहीं आपको बताएगा ये सेम ग्रेवी है, ठीक है? बट होती वही है. Similarly, it is
चिकन को प्याला बन गया, पनीर को प्याला बन गया.
whatever. So this is all variant, okay?
The standard deviation of y.
Standard deviation of y को हमने भगा दिया, उसकी जगह standard deviation of x को ला दिया, ठीक है? Now again I want you to be further confused. So what I will say, I don't say it is standard deviation x into standard deviation x. I will say it is variance of x. So beta, so this is not covariance xy, this becomes beta. So beta is equal to covariance of x and y divided by standard deviation of x into standard deviation of x. But I know that standard deviation into standard deviation will be square of standard deviation, which will be variance. So I will say beta equal to covariance xy upon. Now you will remember me, right? This is clear. What is beta? Is this clear? Now, whenever we are doing covariance or whenever we are doing correlation, we are assuming that both x and y are ratio scale. Whenever we are doing correlation or whenever we are doing covariance, we are assuming that both x and y are ratio scale. Both x and y are ratio scale. If one of them is not in ratio scale, the covariance will not make any sense. Just आप इसको मैथमेटिकली सोचो, आपको सब समझ आ जाएगा. मेरे पास एक वेरिएबल है 1 1 0 1 1 0 0 1 1 1 0. अब इसका मैं मीन निकालूंगा और 1 में से मीन, सपोज दैट मीन इज कमिंग टू बी 2 और लेट अस से मीन इज कमिंग टू बी 0.6. So 1 minus 0.6 will be, so it will be 0.4 0.4. ये क्या है इसका, कुछ मतलब आएगा? So what I am saying, covariance is the variance between two quantity where it was. And now one of them is not varying at all. Will this entire term make any sense? It makes no sense. And hence, whenever you have a dummy variable, the covariance, correlation, all these things make no sense. And hence, whenever we, and r square, one more thing. R square, so I had correlation. In regression, we have something called r square. R square is nothing but the square of correlation. So in regression, we have two things. One is beta, one is r square. Beta is this, r square is square of correlation. So if my independent variable x, if my independent variable is a dummy variable, r square does not make sense. But if my dependent variable is a dummy variable, then r square also does not make sense and this also does not make any sense. Right? क्योंकि पहले तो x denominator में है, but now your y itself is dummy. This does not make sense. So again I am repeating, if my independent variable is a dummy variable, r square does not make sense. And if my dependent variable is a dummy variable, my r square and my beta both don't make any sense. So I have to modify this. Now it is clear. अब आपको समझ आया? आपको समझ आया? Is it clear?
Nice.
Now, what are we saying? So we were talking, now coming back to the problem about the shopping behavior. Now whenever I am studying shopping behavior, what is the values I was giving? So I am writing in short BD. BD means buying decision. 1 means you have bought something, 0 means you have not bought anything. It will be looking something like this. Now can I do normal regression? No, because beta does not make sense, R square does not make any sense. So what I will be doing, rather than, so in beta, what does beta actually signify? In a normal regression, what does beta signify? Slope. Or the magnitude of change in y with a 1 unit change in x. Simple. So the degree of change in y with reference to x. Similarly, in this kind of regression, we will not try to find out the degree of change, we will try to find out the probability of change. Okay, earlier we were finding what? Degree. Now we are finding probability. This is a fundamental difference. Most people do not understand this. Most people in logic model, in probit model, say like this. So I am having x1 to be 0.2, so 1 unit change in y will change, 1 unit change in x will change my y by 0.2 unit. अरे बाबा वो 0.2 यूनिट से नहीं चेंज होगा, 0 को 0.2 यूनिट से चेंज करोगे तो क्या होगा? क्या मिलेगा आपको? नथिंग. अब 1 को 0.2 यूनिट से चेंज करोगे तो क्या मिलेगा? नहीं, क्या मिलेगा? 1 को 0.2 से बढ़ाओगे तो 1 ही रहेगा. कहाँ से मैथमेटिक्स सीखी आपने? ठीक है. Now think this. I am either getting a value of 0 or 1.2. If this 0 makes sense, but this is new 0, बड़ा वाला 0 है, इसमें 0.2 ऐड है. ठीक है. तो ये बड़ा वाला 0 और छोटे वाले 0 को हम डिस्टिंग्विश कर सकते हैं. अच्छा, ये 1.2, ये तो बड़ा वाला 1 है. अब हम इसको डिस्टिंग्विश कर सकते हैं. But I am telling if somebody is buying something, I am naming it 1. What is the meaning of this 1.2? मैं थोड़ा ज़्यादा बाय करूँ. Does not make any sense, right? And hence you should not interpret your result. Right? Because you see, I am having only values 0 and 1. My dependent variable can only take the value of 0 and 1. If my model is telling that your dependent variable will become 1.6, how does it matter? I just want to know whether it is 1 or 0, whether you will buy or not. अब तुमने कब खरीदा, कितना, how much you bought, where you bought, I am not concerned. Or whether you bought once or whether you bought twice, or how long you took to buy a particular thing, I am not concerned. Right? I am concerned with whether you are buying or not. Hence, what I will do, I will try to find out the probability that whether you are buying or not. And then I will keep a cutoff probability. So, I am saying that, and I will try to find out a long-term probability. So, from this model, I will find out certain independent variable. And I know that if I change this independent variable, my probability of buying will increase by 20%. Now it is making sense, right? So earlier, if every 100 people used to buy, if every 100 people used to come, every 10 used to buy, right? Now I am telling my probability of buying, if I do something, my probability of buying will go up by 20%. Means out of 100 people will buy, 100 people who come, every 12 people will buy. Now this makes sense? But 1.2 was not making sense. This is making sense. Earlier I was not doing anything, so out of every 100 people, 10 people were buying. But I know now I have understood what are the variables which are impacting buying decision I am working on those variables, and once I have improved those variables, out of every 100 people who are visiting, 12 are right. So the probability of buying has gone up by 20%. So these are the kind of analysis which we have to do in these type of things. So whenever we have a dummy variable as my dependent variable, I have to be concerned with the probability, not the actual change in reference to x. So when do we, now let us talk about, so there are three types of things: logit, probit and tobit. I will be very quickly coming to tobit, but logit and probit basically are two forms of the same thing. When your variable is a dummy variable, 1 and 0. Now when we can apply this kind of, so there are many settings where we can apply logit and probit model. For example, if we want to do employee behavior, so whether an employee will stick with my organization or not, and what are the factors which are affecting my employee turnover, right? So a person who is having an intention to leave, I will give him a value 1, and who are not intending to leave, I will give a value 0. Now I can predict how many employees are going to leave in a particular year, so that I can recruit those many employees and my work should not stop. Similarly, whenever I am having multiple distributors, so some of the distributors do delay in supplying, but they will not do delay at all at once. So at one particular point of time, how many distributors will make a delay, or what is the probability that a particular distributor will do a delay. Similarly, we can do in terms of stock pricing. So there is a probability that the stock price may go up or the stock price may come down. Now I am not interested in actual increase or decrease. So it may increase by 2%, 5%, 10%, whatever. I am concerned whether it is increasing or decreasing. So what I will say, I will create a model like this. If my stock return is increasing, I will give it a value 1, and if it is decreasing, I will give it a value 0. And then I can analyze what are the factors on which it is determined that when my stock price will go up and when my stock price will come down, right? So these kind of models I can use. There are n number of models, especially in social sciences. So whenever we are talking about price elasticity, prices are going up, prices are coming down, or probability somebody will buy, probability somebody will not buy, probability a distributor will supply in time, probability a distributor will not supply in time. Nowadays we also have this online shopping, where we give something called cash on delivery, right? So whenever I am giving something on cash on delivery, there is a chances that the goods may come back. So I can also formulate a model, and I can predict the chances of a goods getting returned whenever I am selling it on cash on delivery mode. Then I can actually decide whether I should give this option of cash on delivery or not. Suppose I am finding that cash on delivery, out of every 100 item cash on delivery, 30 or 40 are coming back. Now is it making sense to sell in cash on delivery? 30 or 40 are coming back, right? So my cost is going up, my sales is not getting converted. So what I will do, I will drop cash on delivery mode. Right? So there are many practical. In fact, there are, for example, we try to predict the reviews of a movie. So whether a movie will get a high review or a low review, whether a particular team will win a championship or not, whether a particular player will win a championship or not, all these kind of prediction can be done using. So these does not have relevance only in pure management. They have a lot of these kind of model, logit and probit model have lots and lots of relevance. Now in management, their relevance becomes much more. Why? Because what happens, championship happens only once. movie releases only once, right? But you do business on a daily basis. If you are selling goods on cash on delivery, do you sell only on Mondays and Tuesdays? You sell on all 7 days. If you are selling on cash on delivery, you have to sell on all 7 days, 365 days a year. It means you have to continuously make a decision. Now, in case of championship, it becomes a normal logic model. But in case of something like this, it becomes a panel logic. Why? Because a time component. Earlier, we were having only cross sections. Out of 100 people, how many people are rejecting goods on cash, goods sold on cash basis? But now we are also having a time component. So if I am selling goods in the month of January, February, March, or if I am selling goods in 2010, 11, 12, 13, over a period of time, I can also see whether the probability has gone up, or the probability of goods returned has gone up or has come down. Right? Hence, rather than having normal logic model, we have to have a panel logic model. Similarly with my distributor. So I am having 10 distributors. So how many distributors do delay and which point of time they do delay? Then I can repeat the same exercise in the next year. Then I can repeat the same exercise in the next year. Probability of a company going bankrupt. So if in 2010 there were some companies who were going bankrupt, then 2011, then 2012, then 2013, probability of companies going bankrupt. Again, you can construct a panel logic model. Similarly, nowadays in banking sector there is a huge cry on NPA, non-performing assets. This non-performing asset can be very, very beautifully modeled through these kind of things. So you can have a panel logic kind of thing where you can actually find out what is the probability that a particular customer will go bankrupt. And see, banks generally have long-term customers. So if you have taken a home loan, you will generally not take a home loan for 1 year. You will generally take it for 20 years. Similarly, if you have taken a car loan, you will generally take it for 4 to 5 years. Similarly, if you have taken an education loan, you have taken it for 7 to 8 years. So what happens? My customers over a period of time are remaining the same. Now I have to see what is the probability that they will default in their payment, or what is the probability that they will become NPA. In situations like this, we can apply panel logic model or panel topic model. So there are many applications. Similarly, in your probability of devaluation or probability of your currency getting depreciated. So suppose my major trade relationship is with US. Now I can find out what is the probability that the rupee will depreciate in terms of dollars. Right? So all these forms of model can be used through logic or panel probability. So if you have a normal data, so if you have purely cross-sectional data, you will have either cross-sectional logic model or cross-sectional probability model. But if you have a panel data setting, then you can go for either a panel logic model and a panel probability model. One more thing, panel logic and panel probability can only be done through REM. Panel logic and panel probability can only be done through REM, they cannot be done through fixed effect. This is only panel REM, panel logic and probability, not normal logic and probability. So normal logic and probability you can do anyways, but if you are doing panel logic and panel probability, you have to always use REM. Right? So you should understand the condition when which model is to be used. So if your data is stationary, you can use regression. If your data is non-stationary, you cannot use regression. If your dependent variable is ratio scale, you can use normal regression, you can use REM, you can use FEM. But if your independent variable is a dummy variable, you have to only use REM. Similarly, if your dependent variable is a categorical variable, then also you have to use REM. So in panel data, always remember that if any of my variable is a categorical variable, whether it is dependent or independent, I cannot use FEM. Because FEM will create dummies for different cross section, and there will be a problem of perfect multicollinearity.
Sir, in this case, we don't need to check Horstman test.
You don't have, see, Horstman test is to decide whether you have to go for FEM or REM. जब आपको पता है आप FEM नहीं कर सकते हो तो आपके पास क्या पता है? अगर हॉस्टमैन टेस्ट बोलता है FEM करो तो आप FEM करोगे? नहीं करोगे.
Sir, in case of interval data, can we use this simple regression?
In case of interval data, you can use simple regression, but its application to panel data is very restricted, and there is no major breakthrough in that point. So we are still the result may not be reliable, but if you are doing a plain simple regression in interval data, that is good enough. So interval data, basically whenever you collect a questionnaire, so you have to rank something from 1 to 5. So 1 may mean very good and 5 may mean very bad. Similarly, 1 may mean very bad, 5 may mean very good, and you are giving a number. That is an example of an interval data. In those kind of data set, you can either do simple regression, you can do factor analysis, cluster analysis. They are basically called multivariate technique. So factor analysis, cluster analysis, normal regression, then you can do structural equation modeling, right?
Logit and probability is also applicable.
Logit and probit is not applicable on interval data. Logit and probit is only applicable on when your dependent variable is a dummy variable.
Sir, in case suppose can we manipulate our questionnaire or can we design our questionnaire like that? In case of that yes or no, can we ask that interval scale kind of the question to get that to apply this simple regression, or it is not advisable?
To apply simple regression, you can use normal interval. That is what I am telling. So if you are having a 5-point scale or a 7-point scale, you can apply normal regression. There is no problem. So you cannot apply panel regression.
That is fine, sir. What I am asking that it is okay to design our questionnaire accordingly, or can
accordingly means what?
Suppose in case that if you are asking
please
that whether you will buy it or not, in place of this yes or no, can we ask that more probability to buy or less probability to buy, or I will not buy?
See, there are two things. One is whether you are trying to estimate a probability of buying. Okay? One, you are estimating the intention to buy. Yes. They are two different things. So if you are having a probability of buying, it will be either 1 or 0. So I will either buy or I will not buy. Okay? So either I am alive or I am dead. It is not like what Jagjit Singh says, जान बाकी है मगर सांस रुकी हो जैसे वो ऐसा नहीं होता है ना. So either I will buy or I will not buy. ठीक है? But if you are telling what is my long-term intention to buy, then you can create. So it should be your objective, not because I want to apply logic. So whether you will buy or not, or just because I have to regression. You have already bought it. Are you planning to buy it? I have already, no. Are you planning to buy it? Right? It does not make any sense. So it is your objective. If your objective is to know probability, yes or no, it will be 1 or 0. If you want to understand intention, I am having some intention, lot of intention, high intention, or there are something which cannot be directly quantified. For example, motivation or happiness. So how happy are you with your job? I cannot say 1 or 0. But on a 10-point or a 12-point scale, I can say, okay, out of 10, I can say that my happiness is 8 or 9. Right? But I cannot say 1 or 0. Or what is your attitude in life? 0 or 1. How can we answer? Is my attitude 0? Is my attitude 1? No, I can't say that. But probability of buying. If you have bought, it is 1, as simple as that. If you have not bought, it is 0. बीच में कुछ थोड़ी है. जान बाकी सांस चुकी, ऐसा तो नहीं है ना, या तो खरीदा है या तो नहीं खरीदा है, सिंपल एज दैट, राइट? सो दैट शुड डिटरमाइन योर choice of the questionnaire. See, choice of questionnaire, choice of methodology, many things depend upon your objective. What is exactly you want to do it. Try to see what you are doing is fulfilling your objective. Okay? Not that it should not be that whatever I am doing is helping me in coming to that methodology. Those things will become apparent. So if you are having something like probability of buying, and you have given 1, 2, 3, 4, 5, right? It does not make any sense, because suppose your value is coming 2.1, can probability of doing something be 2.1? No. Why no? Because probability always lies between 0 and 1. So if I am getting something, the probability of him doing something is 2.1. How does it matter? I mean, does not make any sense. Or probability of doing something is minus 2.7. This is making no sense, right? So your objective and your questionnaire or whatever data you are having should be framed in such a manner, right?
So can you show one data set related to logic panel model?
Any data set which is having a dependent variable as 0 or 1 will be conducive for logit and probit model. Only thing is that if it is a cross-sectional data, you will do normal logit and normal probit. But if it is a panel data, you will do panel logit and panel probit. Right? I'll show you also one or two. We'll try to see one or two data sets how they appear like and how to. Okay, one more thing. Sometimes what happens? The difference between the categories are not very high. But you have a ratio scale variable, but the difference between the ratio scale is not moving much. In that case also it is advisable to convert that scale into a dummy variable. So if you are above a cutoff level, you will be 1. If you are below a cutoff level, you will be 0. Right? For example, whenever we are doing movies ranking, so movies rating can be something like that: 8.1, 7.9, 5.4, 2.7. Now this is exactly not a logic model. However, I can define that 7.5 is cutoff. So a movie getting a review of more than 7.5 will get a value 1, and which is getting a value below 7.5 will get a 0. So it will become 1, 1, 0, 0, 1, 0, 0, 1, something like this. That also you can do, and many people do it. Similarly, stock price. So stock prices, can go up by 5%, 2% in a daily basis. They can go up by a small margin. They will not go up by huge margin. So margin is not relevant. What is relevant is whether they have gone up or they have come down. So if they have gone up, I will mark it as 1. So if your stock return is positive, irrespective of its magnitude, it will be 1. And if it is negative, it will become 0. That also things you can do. So you can convert a ratio scale into a nominal scale. That is not a problem. Always remember that a ratio scale can be converted into a nominal scale. A ratio scale can be converted into an interval scale. An interval scale can also be converted into a nominal scale. So the hierarchy is like this: nominal, then ordinal, then interval, and ratio. And in this, but only thing is that in this chain I can only move back, I cannot move front. So ratio scale can be converted into interval, it can be converted into ordinal, it can be converted into nominal. But nominal cannot be converted into ordinal. Right? So ratio scale can be converted into interval, interval can be converted into ordinal, ordinal can be converted into nominal. Similarly, interval can be ratio scale can be converted into ordinal, interval scale can be converted into nominal. But nominal cannot be converted into ordinal, nominal cannot be converted into interval, nominal cannot be converted into ratio. So always remember this chain. Only thing is that here we can only go in reverse direction. We cannot go in the forward direction. Okay, so ratio scale is the highest form of scale. Whatever mathematical operations are there, plus, minus, multiplication, divide, under root, square, cube, 1 upon under root, taking logarithm, taking exponential, taking correlation, all those things you can do with ratio scale. So you have to take exponential, you have to take log, you have to take log difference, whatever you want to do, you can do with ratio scale. But most of the things you cannot do with other things. For example, taking log. Taking log of nominal value does not make any sense. Right? Similarly, taking log of ordinal does not make any sense. And so is for interval. But for ratio scale, you can take a log. Right? तो आपका r स्क्वायर सिग्निफिकेंट r स्क्वायर मीनिंगफुल नहीं होगा, बाकी चीजें तो वैसे ही होंगी ना. हमने तो बताया था ना डमी वेरिएबल के ऊपर. इंडिपेंडेंट वेरिएबल इज 1 और 0 मींस इंडिपेंडेंट वेरिएबल इज अ डमी वेरिएबल. आई टोल्ड यू देयर आर टू टाइप्स ऑफ डमी, वन इज एडिटिव डमी एंड मल्टीप्लिकेटिव डमी. एडिटिव डमी मींस डिफरेंस इन इंटरसेप्ट, मल्टीप्लिकेटिव डमी मींस डिफरेंस इन स्लोप. ठीक है, क्या प्रॉब्लम है? Your independent variable can be a dummy variable, that is not a problem. Only thing you have to make sure is that whenever your independent variable is a dummy variable, your r square is not meaningful. You should not look at your r square. ठीक है? Is this clear? Any doubt? Just mentally think how your data, any data set, how does it look? Whether it is, so first what you will do stationarity. Then after doing stationarity, you will check your dependent variable, you will check your independent variable. Whether your dependent variable is categorical or it is a continuous variable. Similarly, your independent variable, are they categorical or they continuous? Right? What is the type of model you will be using? Whether you will be using a simple regression, poor regression, panel regression, FEM or REM, or you will be using a logic model or a probit model, right? So try to keep things. So your things should be clarifying one at a time. Okay, so you should always proceed one at a time. Okay, this is my data set. First I will see stationarity, then I will see my dependent variable, then I will see my independent variable. Okay, independent variable are all ratio scale, so I can go for any model. Now my dependent variable is also ratio scale, so I will go for either normal regression, poor regression, panel regression. In panel regression also I can do both REM and FEM. So I will do a Hausman test and check whether it is REM is more applicable or FEM is more applicable. Then if my independent variable is having a dummy variable, I can only use REM. If my dependent variable is also a dummy variable, then I cannot use this model, I have to use some of these models. And then also I will have to use REM. Now comes Tobit model. Tobit is actually nothing but truncated logic model. Again, this truncated word is there to confuse you. Sometimes it is also called a censored model. So whenever we hear of censor, we remember about Mahesh. Okay? So you are telling what has this topic to do with Mahesh Bhatt? है ना? महेश भट्ट की पिक्चर वैसे ही नहीं समझ आती, ऊपर से इसने ये टॉपिक भी ला दिया. So what is this censored? Censored does not, censored simply means I can either have something which have different quantities and I can not have anything at all. Okay? So let us take our, again I am repeating, in censored regression, in logit and probit, we only have two categories, 0 and 1. However, in censored, we bring little bit more complexity. So we are telling that, earlier I was telling that whether somebody is either buying or he is not buying. Now I am also telling one more thing, either you are buying or not buying, and if you are not, if you are buying, how much you are buying. So earlier I was telling whether you are buying or not. Now I am telling whether you are buying or you are not buying, and if you are buying, how much you are buying. So how earlier my data was like this. One, if it is coming down, it will take the actual value. Whether it is going down by 1%, 2%, 5%, 10%, 20%, all those things. Right? VAR means value at risk. This VAR means vector autoregression, which we will be discussing. So how do we model them and how do we interpret them? So first thing, in logit and probit, we only interpret them in terms of positive probability, in terms of their impact on probability. So if I have a regression like this, y equal to alpha plus beta 1 x1 plus beta 2 x2 plus u1. Y is nothing but my probability of a customer going default. It is taking value of only 1 and 0. So it is a kind of logit model or a probit model. Right? So suppose x1 represent my age and x2 represent my education. Right? Now, why is the probability that a customer will default in a payment? Now, this beta 1, suppose beta 1 is having a positive value and beta 2 is having a negative value. Then how we will interpret? We will interpret that with every increase in age, the probability of my going default increases. This is not the change in probability or the change in value of y. This is the probability that I will default actually increases. So if I am going older and older, my probability of defaulting on a loan increases. Similarly, education has given me a negative value. It means what? If I am more and more educated, then my probability of default will come down. So based on this information, what the banker will take decision? What is the banker decision? Whom should we give loan to?
Educated.
People who are more educated and people who are less young. Who are young? Young and more educated. So I will, this is G. So people who are young and people who are educated. I will not give loan to people who are aged or who are less educated. Okay? Is it clear? So this is how we should interpret in logit and probit model. In probit model also the interpretation is somewhat similar, but there have to be some modification have to be made. Achha, one more thing, whenever we are doing logit or probit model, we are not taking them in normal form, we are taking them in exponential form. So if you have to find out the true coefficient, you have to take the log. Again, it might sound complicated, but it is not complicated. So if I am saying that there is a value x and I am defining exponential of x equal to y, then if I do log of y, I will get it. Okay? So if there is a value x whose exponential is y, if I do log of y, I will get the basic value of it. तो कोई भी चीज अगर एक्सपोनेंशियल में है उसको यूनिट में कन्वर्ट करना है तो आप उसका लॉग. So I can also write like this: log of exponential of x is equal to x. Okay? Because log and exponential will cancel each other. So what happened in a logit model? Our beta, actually what we do, because we cannot, I told you we cannot find covariance or correlation directly because my y is a categorical variable or a dummy variable. What I do, I convert them into some exponential form. Now there is a technical thing, you don't have to go into that technicality. We convert all the x into their exponential form. So whatever values of beta we are getting are in exponential form. And in order to find out the true beta, we have to convert them into normal form. How we convert them into normal form? We are taking log of beta 1 and log of beta 2. But by taking the log, your plus and minus will not change. Why we are actually taking this? Because see what happens, log of a negative number is not defined. And your probability can also never be negative. And hence in order to keep everything positive, we do this. Okay? So there are a lot of references available. So this is one thing. So Tobit model interpretation is almost similar to these two, but certain more modification have to be incorporated, and its interpretation is not very simple. Sometimes, but you have to understand. See, coefficient can be having a positive sign or a negative sign. So the sign is meaningful. However, the value of the coefficient is very difficult to interpret. And hence, when you are doing logic probit or Tobit for the first time, you should only focus on the sign, whether it is plus sign or a minus sign. You should not focus too much on the magnitude. In a normal regression or a parallel regression, FEM, REM, you have to focus on both sign and magnitude of the coefficient, but in logic probit Tobit, in the initial time only focus on the sign. Don't focus on the coefficient. Right? Once you have become acquainted, once you have practiced lot, and then you can go on interpreting their magnitude also. But initially, whenever you are doing logic probit or Tobit, only focus on the sign. Right?
But they have to be significant first.
Let's see.
Even if you don't consider
If something is insignificant, it means what? Its value is equal to 0. 0 is positive or negative? 0 is positive or negative? So what is the use? So you are telling it is 0 and it is positive. It is negative. It is 0 but it is negative. That's not mean. Either it is positive or negative, not 0. Okay, 0 will be then Jagjit Singh वाला case है ना, तो उसका कोई फायदा नहीं है.
So we check significance if it is
Significant, then all see. All the result interpretation first depend upon significance. Something is not significant is not significant. You don't have to worry about non-significant. Right?
So please tell us about the odd ratio in this one. Odd ratio.
Actually, there is something called odd ratio and log odd ratio. So, this is derived from odds. You know odds? So, for example, we are telling probability that you will get a head is 1 by 2. What is the probability of getting a tail is also 1 by 2. So, what is log in favor, odd in favor of a head? 1 by 2. What is odds against head? 1 by 2. So what is odd ratio? 1:2.
So that's sir, why we will get in terms of the odd ratio? I haven't heard that language.
Odd ratio is this 1:1. What is this meaning? The first value is in my favor. The second value is in my against. So I am seeing whether the value in my favor is equal to or more than or less than against. So if I am having odds ratio of 1:2, it means the probability of happening that thing is very less compared to the probability of that thing not happening. But if I am having my odds ratio at like 1:0.3, so the probability of something happening is much more than something not.
So what is selection bias in Tobit model and there is selection bias?
See, actually what happened, we are talking about a data set which is very heterogeneous. Very heterogeneous. So we are having 0, 0, 0 and all of a sudden 7,000. All of a sudden 1 lakh. Right? And hence whenever we are dealing with any such data set, there are certain issues, there are certain complicated issues which I don't want to take up now, but there can be certain biases. So somebody will say it is a selection bias, somebody will say it is a scale bias, right? Somebody will say it is a randomness bias, because it is not a truly random. So see, always remember, any kind of form of regression is dependent upon randomness. I told you my error is random, pure noise. But whenever we are introducing a data set like this 0, 0, 0, 2000, 7000, the randomness is not spread equally across. So some people also say that it is a randomness bias, right? So those kind of complexities are there. But my point here is, before going to those complexities, try to first understand the meaning of what is happening. Try to see what is happening. Try to understand its implications. And then you will see what are the problems, how to correct them, right? So those kind of things will be handled. So shall we go for a very quick break and come back in 5 minutes? 10 minutes, 10 minutes. Started with data and stationarity, then I told the stationarity may be there, stationarity may not be there. Now some of the people are confused. Okay, first let me talk about non-stationarity, then I will cover those points. So in after checking stationarity, you check dependent variable, whether it is ratio scale or nominal scale. If it is ratio scale, you can either do pool data, panel data, FEM or REM. But if either of your dependent variable or independent variable is a dummy, you cannot do FEM, you have to do only REM. If your dependent variable is nominal, you have to either go for logic model, profit model or a Tobit model, and they all are done with the help of REM. All these three can be done using REM. You cannot use FEM. Right? So, for example, every kind of technique has some suitability. For example, FEM. FEM can be applied to dynamic panel, REM cannot be applied to dynamic panel. Similarly, REM can be applied to your logic and profit model and model containing dummy variable. However, REM cannot be applied to dynamic panel. So there are certain advantages and limitations of each and every methodology which you do. Then okay, here you can also do one thing. Then FEM can be done on so it can be a static panel or a dynamic panel. There is one more thing called non-stationary panel, or there is one more thing called threshold panel, which I am not introducing here. I will be just after once we complete here, I will just give you one glimpse of threshold panel. So those who are interested can pursue it further, and I will give you the most relevant references. This is clear. So FEM can be in static panel and dynamic panel. Both REM can be applied only in the static panel. Right? Now let us come to non-stationarity. I told you earlier that whenever our data set is having a unit root, we are having a non-stationarity. So unit root is equal to non-stationarity. How to test for unit root? There is a simple test for. Have you done the test for unit root? ADF, PP and KPSS. There are three most important tests for unit root. They are ADF, PP and KPSS. Similarly, you can test for unit root in a panel data setting. That is called panel unit root test. So if you are testing a unit root in a normal data, it is called as unit root test. If you are testing unit root in a panel data, it is called as panel unit root test. Right? So panel unit root tests are nothing but the modified form of all those. So like we have ADF in normal unit root, we have ADF based Fisher unit root test in panel data. Right? So non-stationarity is a condition when there is a unit root. Now that there are multiple methods of handling unit root, the most important method of handling is taking the first difference, which is nothing but which is also called the I1 process. So I0 means a process which is stationary in its base form. I1 means a process which is not stationary but becomes stationarity if we difference it once. Similarly, I have I2. It means a process which is not stationary in its base form. It is not stationary when I difference it once, but it will become stationarity when I will difference it twice. Right? Whenever we have non-stationary data, we cannot apply the normal regression. So I have data. I have to see whether it is having a unit root or not. If it is not having unit root, it is a stationary process. Stationary process is also called as I0. I means integration, 0 means 0 time. So I have to integrate with 0 time. Means don't have to do anything. Then comes first difference. First difference means my data is not stationary, means it is having a unit root, but I am taking first difference. First difference means nothing but suppose I have y1, y2, y3, y4. I will do y2 minus y1, y3 minus y2, and so on. If I do like this, my data will become stationary. Okay? And therefore it is called as integral of order 1 or I1. Similarly, if my data is not stationary, it is not becoming stationary by differencing it once, but it is becoming stationarity by differencing it twice. Hence, it will become a I2 process. Right? Now, ideally, your data set should have the variables which are of same I. So all the data should be either I0, or they should be all I1, or they should be I2. Sometimes what happens, this is not the case. So that becomes a very specific scenario, and depending upon case to case, you have to go about solving it. Right? In some case, what you can do, you can difference one of the variable once and one of the variable twice. Or you can, take the log difference, and there are many things which can be done, but it is a very case to case specific. Ideally, you should have a data with uniform integral. Then there is also one advanced techniques like distributed lag. We also call ARDL techniques. So there are multiple techniques which are they are coming up. So many technologies are being developed which have the ability to handle such type of data. But I will strongly suggest you do not use those techniques unless you are very familiar with the basic techniques, because their interpretation and the interpretation of basic techniques have some differences. Unless you know that, it will become very complicated to make meaning out of it. The most important thing is what is the meaning we are making out of any methodology. Right? So first thing is what is the meaning which is being generated. Now comes the question. Suppose, so I will be taking a very simple case that all my processes are I1. All my variables, so my data is non-stationary and all the variables are I1. We will be only discussing that case. Right? So what we have to do? First, I found out my data is non-stationary. I know I cannot perform normal regression, but I have to perform some advanced regression-based techniques on me. Hence, I have to convert it into stationary. So how I convert? For the time being, I will do first difference or I1. Right? Now, because this is not stationary in the unit form, I have to also test for some advanced things. Right? So, I am having different, so I am talking about a multivariate scenario. So if I am having, again, there can be two things. Either my variables are all independent, they are all behaving, they have no correlation with one another, they are behaving separately. Then I can do two things: mean modeling and variance modeling. So non-stationarity divided into two things. Should I clean this? This side I should clean. So we are only talking about now non-stationarity processes. Acha, one more thing. In stationarity processes, we are talking about dependence. In stationarity process, we talk about dependence. In non-stationarity process, we talk about causality. In stationary process, we talk about dependence. That is why it dependent. But in non-stationary processes, we are basically focused on causality. What is causing what? Because non-stationarity itself means there is a very huge randomness. Because of me or because of others. Okay, so if it is caused because of me, randomness can either be in my mean or it can be in my variance. If it is caused by others, I have to find out what is the cause. Again, I am repeating. Variation. So the data is behaving abruptly. Okay. Now, why it is behaving abruptly? Is some problem with my mean? Is some problem with my variance? Or is some problem with some another variable which is causing me? Right? First, let us talk about a univariate case. That is, I am telling whatever is happening to a particular series is happening because of its own characteristics, not because of the characteristics of other variables. Hence, we call that a univariate analysis. Now remember, all these things what we are doing here can be done in both time series as well as panel data. But which kind of panel data? Short or long? Long panel. Long panel is a panel which is having many time periods. Don't do these things in short panel, please. Okay? So long panel means minimum 15 MA and ARIMA. So AR means there is some problem with the mean. I will correct the mean. MA means there is a problem with the error term. My error term is related to my past error term, and hence it will become MA. ARIMA here I mean this I. How many times I have to integrate? Similarly, in variance model, I am having arch and gauge. Okay, arch and gauge. So arch means autoregressive conditional heteroscedasticity. Gauge means generalized autoregressive conditional heteroscedasticity. Again, these terms are to confuse you. That's all. There is no big thing. So what they are telling, autoregressive conditional heteroscedasticity. In white noise, what we say, there should be no heteroscedasticity. First, they are telling that there is a heteroscedasticity. That is, my error term is varying over time or over cross section. Because this is more focused on time, we are saying that error term is, the variance of error term is not homogeneous. The variance of the error term is heterogeneous. Now in arch, we try to find out the variance of the error term. So what I am telling, in arch, variance of my error term depends upon the square value of the error terms. ठीक है? So variance of the error term today depends upon the square value of the error term yesterday or many periods in back. Similarly, in gauge term, we say that the variance of the error term not only depends upon the square of the error terms, it also depends upon its own past values. Right? So in arch, we have something like this: sigma square equal to alpha plus beta ui. U is my error term. Okay, beta ui t minus 1 square. This is my arch term. In gauge, we have something like sigma square equal to alpha plus lambda sigma square I t minus 1 plus beta ui t minus 1 square. This becomes my gauge term, this becomes my arch term. So there is, in here, in these, we are telling that there is some problem in my mean. My mean is related to my past mean. Autoregression. Y is related to its past Y. Somewhat similar to what we did in dynamic panel. But in dynamic panel we assume that there is not perfect correlation. So y is not equal to alpha plus 1 into yt minus 1. That coefficient of lambda in dynamic panel is very small, 0.1, 0.2, something like that. Then moving average means there is a problem in my error term. My error terms, not the square of the error term. Always remember, in MA it is AR and MA it is my mean and the error term in their base form. In variance, it is the square of the error term. It is the variance of the error term. So variance of the error term depends either on my square value of the error term. This becomes a arch 1 model. This becomes a Garch 1 model. So first term represents the Garch model and second term represents the arch model. This arch is also sometimes written as Garch 01. So Garch 01 and arch 1 are basically the same. Garch 0 means this term is becoming 0. We only have a arch. Right? So first thing we check for non-stationarity, then we see whether the variables are depending on themselves or there is some correlation among different variables. Then what we do when we go for, but if we have multivariate data, then we also have to see whether there is some relationship among variables or not. How we do that? So we first thing is vector auto regression. Now this term again is there to haunt you. There is no technicality, much technicality in it. Only thing is you should understand what is happening. Vector auto regression. What is the meaning of this vector? Okay, one more thing. If you are taking a purely time series data, it is called vector auto regression. If you are having a panel data, it is called panel vector auto regression. So you can either have VAR, or if it is a panel data, you can also have panel VAR. Okay? So let us try to understand very simply what do VAR and panel VAR say. Now, auto relation means what? If there are two variables x and y, right? So yit equal to alpha plus beta xit plus ui. This is a normal one-way causality model or one-way dependence model. However, if I have something like xit equal to alpha dash plus beta dash yit plus epsilon I, this is it, epsilon it. This is called as autoregression. Okay? So I am saying I am related to x is related to me. So there is a two-way causality. However, rather than taking this in normal form, if I take this in a vector form, so I have y which is dependent on, okay, here one more thing is come, sorry, I missed one thing. Plus lambda yit minus 1 plus uit plus lambda dash xit minus 1 plus epsilon it. Right? Now what I am saying, I am dependent on some variable or its past value and my own past value. Similarly, another variable dependent on me or my past value and its own past value. So here it can also be yit minus 1, yit minus 2. Right? I can extend this logic. So rather than xit, I can have xit minus 1. So in a vector form, in a metric, vector is a matrix with either one row or one column, right? So hence the name has come vector autoregression. There is no technicality there. Vector autoregression simply means rather than having only x1, I can have something like this: yit equal to alpha plus beta 1 xit minus 1 plus beta 2 xit minus 2 plus beta 3 xit minus 3 plus lambda 1 yit minus 1 plus lambda 2 yit minus 2 plus lambda 3 yit minus 3 plus uit. I can also have a like this, but what happens if many terms will come? This equation will become unmanageable to understand. Okay, hence what I do, I convert it to a vector. So rather than beta 1, beta 2, beta 3, what I will write? I will write it this in all a vector form. So alpha plus, you can write like this: beta 1, beta 2, beta n, and here you can write xit minus 1, xit minus 2, xit minus. So the product will be this into this plus this into this. This is written in a vector form. Similarly, I can do for lambda 1, lambda 2, lambda 3, into yit minus 1, yit minus 2. Right? And hence this is called vector autoregression. Means y is dependent on x and past value of x and past value of y. X is also dependent on past value of y and past value of x. Right? Now, what happens sometimes? What happens sometimes that in panel data we not only have VAR, but in normal data we not only have VAR term, but we also have an error correction term. Right? What is the meaning of this error correction term? You simply don't worry about this error correction term. So what they are trying to say is that, so although the y is impacting x and x is impacting y, over a long time there is some error correction model. Means they have a tendency either to come together or they have a tendency to spread out. So suppose I am having two series. One series is like this and one series is like this, right? So what we are telling, the two series are getting segregated, but in the long run they are having a tendency to come together. So there is a error correction term. So there is an error, but that error is slowly moving away, and hence we have to introduce a error correction term. So whenever we have an error correction term, we also should check for co-integration. Okay? We should also check for co-integration. What is the technical definition of co-integration? Again, technical definition of co-integration is very simple. Suppose there are two series which are of I1, or any for that matter, we will start with I1, then we will move to other form. So if there are two series, let us say y and x, they are both of order 1, I1. But if any linear combination of them is stationary, so suppose if I say y equal to alpha, so y equal to theta 1 plus theta 2 x1 plus epsilon I. Okay? If this equation is stationary, then I say x and y are co-integrated. But this is the equation. How I can find whether they are stationary or not? You can do a very simple thing. You have this epsilon this side. Keep epsilon this side and take all other terms that side. So epsilon I will become yit minus theta 1 minus theta 2 xit. Right? Yes or no? Now epsilon it is nothing but a linear combination of x and y. What is the power of y? Theta 1, theta 2. So it's a linear combination. Now I will see whether epsilon 1 is stationary or not. If this is stationary, I will say x and y are co-integrated. Okay? So if two series are itself non-stationary, but their linear combination is stationary, then they are co-integrated. Similarly, if there are two series x and y, both are of order I2, but their linear combination is either I1 or I0, then also the two variables are co-integrated. Okay? So what is the technical definition of a co-integration? If two series are non-stationary but their linear combination is stationary, then the two variables are co-integrated. Or if two variables are of a higher integral but their linear combination is of a lower integral, then they are also co-integrated.
Second one.
If two series are non-stationary in their base form but their linear combination, if two series are not stationary in their base form but their linear combination is stationary, then we say that the two variables are co-integrated. So whenever we have VCM, we also do for co-integration. Okay? So whenever there is VCM, you should mandatorily do co-integration. Final thing we do in multivariate is causality. Right? So causality tests basically tell us whether x is causing some movement in y or y is causing some movement in x, or both are causing movement in one another. So sometimes you have something called lead-lag relationship. For example, your spot price and your future price. There is a debate whether spot price is reflective of future price or future price is reflective of spot price. In that case, you have to do Granger's causality. So there are various causality tests. One of the famous causality tests is Granger causality test. In that case, you have to do causality. Similarly, whether GDP is causing inflation or inflation is causing GDP. Whether GDP is causing export or export is causing GDP. Whether GDP is causing capital formation or capital formation is causing GDP. Whether India's GDP is dependent on China's GDP or China's GDP is dependent on India's GDP. You have to do causality. right? So whenever there is a strong intuition or when there is a strong theory that the two variables can cause one another, then we should mandatorily check for causality. Whether GDP is causing stock market movement or stock market movement is causing GDP. Whether interest rate is causing exchange rate or exchange rate is causing interest rate, we have to do causality. Right? So there are multiple applications of causality. Multiple applications of causality. So whether poverty reduction programs are causing poverty or poverty itself is causing the number of poverty reduction program to increase, or whether education is causing female mortality rate or child mortality rate, or child mortality rate is causing education, is having an impact on education. So both way causes are possible. In that kind of thing you also can do. Similarly, in firm performance we see that capital structure may impact profitability, profitability may impact capital structure. Capital structure may impact size, size may impact capital structure. So there can be two-way causality. Right? Similarly, in marketing we have, so whether marketing causes increased sale or increased sale causes us to go for more marketing. Similarly, R&D. So whether our R&D is causing our production to increase, or because we are producing more, we are spending more on R&D. Right? This is, now one more thing. Whenever there is a two-way causality, there is a problem of endogeneity. Whenever there is a two-way causality, there is a problem of endogeneity. Now see, this whatever I am telling is true for both panel data and time series data. Okay? So you can do panel VAR, you can do panel VECN, you can also do panel co-integration.
Then there is a problem of heterogeneity, we can do all these.
No. Whenever you have non-stationary, so non-stationarity can either be normal time series data or panel data. So whenever you have non-stationarity in normal data, you will do VAR. But if there is non-stationarity in panel data, you will do panel VAR. Similarly, when there is non-stationarity in normal time series data, you will do VECN. If it is in panel data, you will do panel VECN. Then you have to test for, if you have a normal time series data, you will do causality. If you have a panel time series data, what you will do? Panel causality.
Can I ask one thing?
Yes, sir.
That is,
Of course.
Like yesterday, what we were talking about, suppose I take one example. That if I am trying to find out determinants of capital structure. So, capital structure is my dependent variable and suppose there are
5, 6 independent variables.
Now you said that before applying the penalty, we have to check for 4 things, which are stationarity, elasticity, multicollinearity and autocorrelation.
Autocorrelation.
So that we have to do on the univariate individual series or
Yes, we have to do it on a univariate series first.
Series first.
And then we will find out whether they are stationary or not. Suppose they are stationary, then you will go for these models.
Panel.
Normal panel. Suppose they are non-stationary, they are based on television.
So if the data is stationary, we are showing causality relation.
If data is stationarity, you don't have to do causality. You have to do dependency. That is what I told. See, if the data is stationary, you have to go for dependency. If the data is non-stationary, you have to convert it into stationarity and check for whether it is one-way causality or two-way causality. Again, I am repeating this point. Many people confuse this point. There is nothing to confuse. First thing, right? So it is just like I go into a house, I knock the bell, so I am conducting census. Okay? First thing, I knock the bell, somebody opens the door. Okay? There's a lady, beautiful lady opening the door. I am asking her, are you married? She is telling no. Then I am asking, how many children you have? Right? So it makes no sense. First I should ask, how many children She will say, I have 2 children. Then I will ask her whether you are married or not. Right? So, you have to make sure what is the question you are asking. The first question is most important. So, the first question here is, what is the first question? No, not are you married. Are you stationary? Don't ask this to a lady. Are you stationary? So, first question which I ask in my data set is my data stationary? There can be only 2 responses. Forget about Jackie's thing for the time being. There can be only 2 responses. Either yes or no. If it is yes, I will go for the stationary model.
So all the univariate series should be stationary.
All the variables should be stationary.
Is non-stationary.
If the single is not stationary, then I told you earlier also, I am again telling, it depends upon situation to situation. Sometimes it is a normal variable, because of something it is becoming non-stationary, then rather than taking the variable, you take the return of that variable or first difference, then it will become stationary.
So we don't need to go here.
Then we don't have to go
If it becomes stationary at level.
here. Again I am telling it depends upon case to case. So there is one variable which is not your prime variable. But you are just including to make the model complete, it is okay. But if you are doing your main variable, then you have to go for higher order model.
And in the example which I am giving to you, like I took this example.
Capital structure. So capital structure and all will be stationary in their base form. You don't have to
If
worry.
it is non-stationary, if in case such data is non-stationary, then should we go for univariate or multivariate?
No, you are telling capital structure is dependent upon so and so thing. Then you have to go for multivariate model.
Sir, stationarity means integrated of order 0 or 1?
I0. Stationarity means I0. If it is non-stationary, then only it will be either I1 or I2 or I3. I1 means I have to difference it once to make it stationary. I2 means I have to difference it twice to make it stationary. I3 means I have to difference it thrice to make it
So
stationary.
it means I1 comes in this
I1 anything, I1, I2, I3, I4, I5, I6, I10, everything comes here. Okay, I10, I20, whatever I you know, it will come here. Only I0 will come here. Okay? So first, what was the first question we asked? Are you ready? No. So the first, I didn't ask you, I was just asking you what is the question I asked. Okay? Are you stationary? So the first question we should ask is my data stationary? If the answer is yes, I will go for normal panel regression technique, which can be FEM, REM, logit, probit, and so on. Then if the data is non-stationary, there begins my problem. If the data is non-stationary, then I have to analyze my variables. Are my variables all behaving on their own, or they are having some relationship with one another? If they are behaving on their own, I will go for univariate modeling, which is again subdivided into 2: mean modeling and variance modeling. And if I believe that the data is having some relationship with one another, I will go for multivariate. Multivariate can either have an error term or do not have an error term. If it does not have an error term, I will go for VAR. If my data is a purely time series, I will go for VAR. If my data is a panel data, I will go for panel VAR. Similarly, if it is having an error correction term, I will go for VECM. So if my data is purely time series, I will go for VECM. If my data is a panel data, I will go for panel VECM. And after doing VECM, the final stage is to see co-integration. So if I am doing VECM, I will be doing co-integration. If I am doing panel VECM, I will be doing the panel co-integration. The final step is to check for causality. So if I am having a normal time series data, I will do normal causality. If I am having a panel data, I will do panel causality. Is it clear? Getting complicated? Little bit? Right? So it is only systematic process you have to. Now once you do it, okay, one more thing. In a normal regression, estimating the beta and interpreting them is very simple. So if you change x by 1 unit, what will a change in y? Or if you change x by 1%, what would be the change in y? However, in VAR, VECM, the interpretation becomes a little bit complicated. Those things are not very simple and will not come in the first time. So you have to read the theory of VAR, VECM again and again and again, especially in a panel. So VAR itself is little bit complicated. In a panel data setting, it becomes much more complicated. Because in a normal time series, we are handling only one cross section. Now we are having multiple cross sections. Right? So what is their VAR among variables or their VAR among cross sections? So if there is VAR only among the variables, you will go for normal time series. But if the VAR is also among different cross sections, then panel VAR become much more important. Similarly, if there is an error correction term only in your variables, you will go for VECM. But if the error correction term is also there in different cross sections, then you will go for panel VECM. Earlier what we were doing whether heterogeneity is there in different cross sections or not. Now we are doing whether there is an auto regression in different cross section or not. So it is an extension of the same logic. पहले हम क्या बोल रहे थे? There should be heterogeneity. So heterogeneity can either be in alpha or in beta, right? So we are talking about cross-sectional heterogeneity. So cross-sectional heterogeneity can either be in alpha or in beta. If it is alpha, we will introduce differential intercept dummy. If it is in beta, we will introduce differential slope dummy. However, now we are asking one more advanced question. Is there auto regression in different cross sections? Is there error correction in different cross sections? If the answer is yes, rather than going for normal VAR or normal VECM, we will go for panel VAR and panel VECM. Similarly, after doing panel VECM, I will say whether the cross sections are co-integrated or not. Right? Then I will go for panel co-integration. And final thing is I will ask for causality. So what is causing what? This is how you should go about doing it. Now estimating them and interpreting them is a little bit complicated topic. It cannot be covered in one session. In fact, you need to have a different workshop altogether because these are very, very, very advanced topics. And my genuine suggestion to you is that I have just introduced it for the sake of completing things. You should not directly jump to that. First, you should start from normal pool data, normal regression pool data, understand their alpha, understand their beta, understand p-value, and slowly go on there. Because if you directly jump on them, many things you will not be able to understand. Okay? This is the thing. Now, we will do one final exercise and then we will stop. So I want you all to observe. Only observe. Okay? For the how many minutes we have? 15, 20 minutes? Okay. No, log does not convert nonce. Okay, one more question is generally asked. Why do we take log of a variable? I will first answer this, then we will move to the final step. Okay, everyone. Can I have your attention, everyone? So there is a perpetual question all the time. Why do we take log of variable? Why do we take log of different variable? There are many purposes for which we do take log. What are the most one or two important purposes we will see. So first most important purpose of taking log. So see, first of all, let me distinguish. So there are two types of log, log and ln. So log and ln are no different. This simply means log to the base 10. This simply means log to the base e. E means exponential. Okay. E number जो होता है ना 2.81 something, right? So this is the log to the base 10 and ln is log to the base E. We will focus only on ln. Log 10 is of not important to us. What is important to us is ln. So whether it is written log E or ln, you should think that they are same. Now, what is the purpose of ln? The first most important purpose of ln is to convert prices into returns. The first most important purpose of ln is to convert prices into return. For example, I am having stock price. Let us say RIL. RIL is having different stock prices. So 1008, 1002, 1007, 1007, 1020, 1027, 1035, 1022, 1040, so on. Right? These are all the prices. Now, if I take log of all these prices and I do L2 minus L1. So this is time period 1, 2, 3, 4, 5, 6, 7, 8. Right? What I will do? I will do log ln of RIL. So I will get some number. Let us say the number is 7.1. Here it will be 7.02. Here it will be 7.11. Something like this. So what I have done? I have taken the raw number, taken their log. Now if I do this minus this, it means ln of P2 minus ln of P1, it will give me return on P2, return on the time 2. Right? Similarly, if I do ln of this minus this, I will get return. But which kind of return this is? This is not normal return. This is called continuous compounded return. This is called continuous compounded return. You know continuous compounded return meaning? Anybody who does not know continuous compounding? You all know continuous compounding? Right? So rather than compounding yearly, we are compounding it monthly. Rather than compounding monthly, we are compounding daily. Rather than compounding daily, we are compounding in every second. So I am finding out the continuous compounded rate of return. How to find out the continuous compounded return? Simply take the ln and find their difference. Okay? So similarly, you will be valuing this minus this, this minus this. Here you will be keep getting the continuous compounded rate of return. First year तो आएगी नहीं ना वैल्यू, क्रॉस हो जाएगी. Whenever you are differencing, you will lose one value. ठीक है? Forget about that. Okay? So whenever you take ln and their difference, you are essentially getting continuous compounded return. That is first thing. One more thing why we take, so this is clear why we take log. This is clear why we take log. Now there is another purpose why we take log. Suppose I am having the assets of different companies, right? I am taking assets of different companies. So there are some companies whose assets are very big. 1,000 crore, 2,000 crore, 10,000 crore, 5,000 crore. And there are some companies whose assets are very small. 10 crore, 15 crore, 20 crore, 100 crore. Now if I bring all of those things in a single regression, what happens? I am artificially creating heterogeneity in data. So जो मेरा error term होगा, it will not be having the condition of homoscedasticity. It will become heteroscedastic. Okay? So if I am having 10,000 crore and 10 crore in the same model, there will be heterogeneity in the data and therefore the error term will become heteroscedastic. In order to avoid that, I take log. So what happens? Suppose I am having a number 10,000 and I am having a number, let us say 300. The difference between them is very, very big. But if I take the log of this number and the log of this number, so the log of this number will come to around 203 something, and the log of this number will come, let us say, 45. Now see the difference between these two numbers. कितना सा हो गया? और ये difference कितना बड़ा हो गया? Right? So earlier what was my difference? Now what is my difference? So earlier there was heterogeneity, huge heterogeneity. My error term were not following the OLS property, but now my error term will follow. So by taking log, we are avoiding heterogeneity in the data. Right? Clear? There is one more importance of taking log. So for what happened? Suppose I have a model YI T. Okay, let us take a simple model. Yi equal to alpha plus beta xi plus ui. Right? Rather than taking y and x in their base, so what does beta here says? Beta is 1 unit change in x. What would be the change in y due to 1 unit change in x? Right? Or the change caused in y due to a change in x, unit change. However, sometimes we are not interested in unit change. We are interested in the relative change or percentage change. So what we will do? We will take log. So how will my equation become? ln yi equal to alpha plus, here it will be alpha dash plus beta dash ln xi plus epsilon I. So here beta was telling what will be a change in y if I change x by 1 unit. Here my beta dash is telling what would be the percentage change in y if I change my x by 1%. Okay, this is also called as elasticity. This is also called as elasticity. So beta will tell me elasticity of y in terms of x. Here beta is telling the difference in y due to change in x. Here beta is telling elasticity of y with reference to x. Right? Is this clear? So these are the three main reasons why we take log. First is to take continuous compounded rate of return. Second is to avoid heterogeneity in data. Third is to take the elasticity or to find out the percentage change in y due to a 1% change in x. I know you all are now in a rush to go. I won't take much time. So this will be the final. Okay, so chalo. I am also now having that feeling that most of you are little bit exhausted. I can understand because I can understand what is happening to me in 3 days. So what would be happening to you in double of that time? You know? So I can empathize with you. So what happens, see, I am just showing you a raw data and what are the things which we have to do in order to convert into a finished data. Then we will do stationarity, we will do multicollinearity and heteroscedasticity. So your raw data will look something like this. The rows are not in order, the columns are not in order. There would be certain missing data, missing value and so on. Sorry? Autocorrelation is basically your Durbin Watson. I'll tell about that also. So here you can see there is a missing data problem. Here you can see total asset of one company is 10273. Another company is 2600, some another company it will be something different. So let us see what are the assets. So for one company it is 85,000. company it is only 6,000. Right? So there are different companies with different asset size, right? So that is one thing. Second thing is we are having many missing values. So you will have problems like this, and also the data is not arranged in a normal panel form. So if I have to do a panel thing, first I have to arrange the data in a panel format. So how I will do that? I have done it in this sheet. So what I have done, I have taken this data. In Excel there is a function called transpose. So in transpose the rows will become column and column will become rows. So let us do one. Okay, so I will copy, paste, special, transpose. Right? Now this is what? This is year. This is company. And these are the different. Now these are raw variables. So for example, sales. This is raw sales. Raw sales is of no use to me. I have to convert into a variable. Similarly, total asset is of no use to me. Now again, I am having different companies for different years. But how I want my data? Company 1, T1, T2, T3. Company 2, T1, T2, T3. So what I will do? I will go via a function called sort. So you have to have two levels. Okay? You have to go sorting by two levels. First I have to sort by the name of the company. Then I have to do sorting by year and do okay. So now your data is arranged in a panel format, which can be understood by e-views, which can be understood by stata. Okay? Now I am having total asset, but I know there is lot of heterogeneity in total asset. So what I should do with that? I should take log. So I will create a variable ln80. ln80 means log of asset equal to, if you type ln, so what was the number? So what was the number here? 10273. What is the number here? So you see the difference? 10,000 has become 9. Similarly, so the difference between the different numbers was very high. However, the difference between these numbers has become very low. Without, and this is without losing any information in the data. So if you compare the variance of this number and the variance of this number, it will be the same. If you compare the correlation of this number with a correlation of any other number, it will be same. Why? Because I told you correlation is independent of scale. We have only changed the scale, we have not changed anything else. Right? That is the advantage of taking log. Similarly, if something is already in percentage form, kindly don't take log. Kindly, sometimes people take log of return also. Kindly don't do it. Request, हाथ जोड़ के request कर रहा हूँ, मत करो उसको. It makes no sense. Log of a percentage makes no sense. Kindly, if you have a return, take it in return form only. So some people do log of return. अरे बाबा log return itself is a return. Log करोगे तो return का return आएगा, क्या फायदा? Log itself is giving you continuous compounded return. First you are taking return, फिर उसका log कर रहे हो. ठीक है? ऐसी हरकतें मत करें. ठीक है? ये शोभा नहीं देती है ना? Right? This is clear?
Yes, sir.
Similarly, what you can do, you can create some variable. For example, I am having profit and sales. So I can create a variable called return on sales, which will be nothing but my profitability divided by my sales. See, what is my genuine suggestion to you? In sometimes you have the ready-made ratios. Some of the database give you ready-made ratios. Kindly don't take the ready-made ratios. In Excel, it hardly takes 1 minute to find the ratio. वो रेशियो खुद निकालो, क्योंकि कई बार उनके रेशियो निकालने का तरीका आपके रेशियो निकालने का तरीका अलग हो सकता है, राइट। समटाइम्स सम रेशियोज माइट बी मिसिंग, फिर आप उसको मिसिंग डेटा ले लोगे, जबकि इसमें से 1 सेकंड में आपको रेशियो मिल जाएगा, ठीक है। Hence, try to, and also if you are comparing different databases, always do all the calculation by yourself. Plus minus multiplication Excel में 2 सेकंड में हो जाता है, kindly do it in Excel. हाँ, दो मत लो, बिल्कुल तो मत लो, ठीक है। आपको इस ये करने में कितना टाइम लगेगा? कुछ भी नहीं लगेगा, कर दो ना, क्या जा रहा है, इतनी आलस किसका, ठीक है, right? So if I do all those techniques plus what I will do here, there are not many data problem, but sometimes what happen in the final year, let us say March 2014, most of the companies are having a missing data. So what I should do, I should use a function called filter, right? And in time what I will do, I will remove 2014, right? And then select all this data and paste in a different work file. यहाँ पे काम मत करना चालू कर देना, इसको कॉपी करके किसी और वर्क फाइल में पेस्ट कर देना. So your 2014 is deleted, entire year is deleted. So sometimes what happens, we have to delete 1 or 2 years. Similarly, suppose there are 2 companies which are creating problem, you can use the filter, you can remove those 2-3 companies and you can take rest of it. Right? So what happens? All this we are doing in order to make our data set a balanced panel. Right? So whenever you have an imbalanced panel, try to convert into a balanced panel. Right? Once you have a final data set, what you have to do, first thing is you have to ask the question. What question, madam? Are you stationary? Good. So how I will do it? So everyone, so what I am doing, for the time being, I am not considering the panel. I am considering the normal data set. Okay, I don't have to create a panel. I am first checking whether my basic data is stationary or not. So what I will do, I will select all the data, copy it, go to eViews and paste as new one file. Okay, finish. So all my data has come. Now I will check for stationarity. So for example, my variable is gross return on asset, GROA. How come it not? Sometimes eViews will perform separately. So we have to close it and start it again. No, you have to do it 2-3 times. After doing 2-3 times, if it is still doing, then you have to go to BRC. इतनी जल्दी क्या BRC करना? So I have a data set. I will go to eViews, simply paste as new work file and finish. Again see whether you have a number. Now, so we don't have to go to BR. Right? So first is GROA. Now I want to see whether it is stationary or not. So what you do, view unit root test. If the null hypothesis is there in a unit root, it means the null hypothesis is that it is not stationary. So hence I have to reject the null hypothesis in order for my data to be stationary. We are rejecting the null hypothesis very comfortably. So my data is stationary. Similarly, I will do, okay, one more thing. There are 3 tests, ADF, PP and KPSS. In ADF and PP, the null hypothesis is that my data is having a unit root and hence it is non-stationary. And in KPS, it is other way around. In KPSS, the null hypothesis is that my data set is stationary. So if you do KPSS, your probability value will be very high and you have to accept the null hypothesis. Let us see if we have KPSS here. Yeah, we have KPSS. Sorry? So whenever you are running any test, always remember what is the null hypothesis, what is the alternate hypothesis. नहीं कोई भी एक करो, कोई भी एक करो. It is just like है ना कि आपको शादी करनी है तो आप गुरुद्वारे भी जा सकते हो, चर्च भी जा सकते हो, मंदिर भी जा सकते हो. तीनों में थोड़ी जाओगे. मंदिर में शादी हो गई, चलो अब गुरुद्वारे में चलते हैं. गुरुद्वारे में हो गई, चलो अब कुबूले करने चलते हैं. ऐसे थोड़ी है. कोर्ट भी जा सकते हैं.
Value for particular year is missing, but that year is significant, so we take it because of the research outcome. Can we
No,
take
that-
the mean value?
If 1 or 2 is missing, you can take. Don't take. So if it is time series data and if it is a value, for example, 2014, so don't take mean. Take the value which is close to 2013. Oh, you are taking mean. Mean will come somewhere in 2007. 2007 का data आज क्या काम का है? ये मेरा छोड़ right? Now, second thing we have to, so first thing we have tested stationarity. And testing for one variable, you have to test for all the variables. ठीक है, एक करके छोड़ मत देना. हमें तो सिखाया गया था एक नहीं, you have to do for all the variables. Then you have to do multicollinearity. How you will do multicollinearity? First you have to specify a simple regression. So estimate equation, what is my GROA is my dependent variable and site and for the time being I am making it NROE. Okay, for the time being, this model is not making any sense. I am just telling you that I have one dependent variable and 2 independent variables. You can have many independent variables. Now you have to check for multicollinearity. So first what you do a normal data. So this is a kind of pool data. I have not defined any panel. I have not done anything. I am just running a normal regression. Right? I will do okay. View. Coefficient diagnosis. You can see your variance inflation factor, everyone. So you got your result. Go to view. Coefficient diagnosis, variance inflation factor. Do okay. Look at centered VIF. If your centered VIF is less than 3 or 4, it means you don't have very high problem of multicollinearity.
If centered VIF is less than 3?
Less than 3, 4, 5, up to 3, 4 it is no, but after 3, 4 the multicollinearity problem is very high. Right? Our VIF is very close to 1. It means there is no acute problem of multicollinearity.
If we see the correlation of the variables,
then also see correlation is a preliminary test. VIF is an advanced test which take partial. See, VIF is also based on correlation, but in correlation we take complete correlation, it takes partial correlation. So it is little bit advanced, but 90% of the cases your result will be similar. If your correlation is low, this will also be low. If your correlation is high, this will also be low. Now the final thing which you do is to check for heteroscedasticity. So there are many things. You can generally go for white. White test.
So how come?
How come it's how come it's an entirely different notation? View residual diagnostic heteroelasticity test. Okay? And white. Okay? Which test you should go? White. Okay? And do okay. So the null hypothesis has been rejected. It means there is some problem of heteroelasticity, and hence whenever you are running the data, rather than taking normal error, you should take heteroelasticity corrected error. How you will do it? I'll again go back to view. This was my output. Then estimate. Rather, here you can see white. Here you can see white. Just click white. So now they have taken heteroelasticity corrected errors. Okay? फिर से करता हूँ, चलो। पहले आप first I run a regression. This is my output. Now I want to test whether there is heteroelasticity or not. How I will do it? Very simple. View residual diagnostic heteroelasticity test white and do OK. Your F statistic, if it is significant, it means there is heteroelasticity. If it is not significant, it means there is no heteroelasticity. Okay? Now, there is a heteroelasticity because my F statistic is significant. Now what I have to do? I have to correct my heteroelasticity. How I correct my heteroelasticity? By taking robust error terms. How I do that? Very simple estimate like I was doing earlier. There is something called option. In option, rather than default model, take the white model. Or you can also go for UV based model. Both are robust model. For the time being we are using white. So now one more thing. You can see here coefficient 1, 0.10, 0.0014, 0.24. You will see that these coefficients will not change. Only the p-values will change. Right? Okay? So this is how we correct for heteroelasticity. Now one more thing is that heteroelasticity cannot be directly checked in a panel data. However, it can be corrected by taking robust error. So if you have to check heteroelasticity in a panel data, you should first check it in a normal data. Okay? Then you should, if there is heteroelasticity, then you should go for robust error terms in your panel data. Otherwise, you can go for normal estimation. Right? The fourth thing is nothing but your autocorrelation. Here you can see something called Durbin-Watson. This is nothing but a test of autocorrelation. If your Durbin-Watson is very close to 2, it means there is no autocorrelation. If the Durbin-Watson is very different from 2, it means there is a autocorrelation. Here you can see Durbin-Watson is 0.89. It means there is a very high autocorrelation, and hence you have to go for some robust error terms. So you should go for auto or you should go for differencing. If you do differencing, your autocorrelation will go away. Right? Durbin-Watson test should be, statistic should be near to 2. Is it near to 2? No. It is very far from 2. It is 0.89. So if your Durbin-Watson statistic is 2, 1.9, 1.8, 2.1, 2.2, something in that range, it means there is no autocorrelation. But if it is like 1 or 3, 4, 5 or 0.2, 0.3, it means there is autocorrelation. If there is autocorrelation, you have to correct the autocorrelation. This can be done in two ways, either by taking the robust error terms or by doing first case.
If we take new west, it automatically corrects for
It new west will correct for both neutral elasticity and autocorrelation. Okay? So should we stop here?
Yes.
Okay. So thank you everyone, and I hope your session would be productive to you, and you will make some use out of it. I wish you all a very happy new year. Thank you. So enjoy now. And now for till New Year, please don't do anything in econometrics. Okay, up to